Good day, everyone. Praise be Jesus and Mary. This is my report about electric current and resistance. What is electric current? Electric current is the flow of electrical charges as electrons from one position to another in some region in space. That rate of flow of electrons produces electrical energy, and the flow of electrons is known as electric current. Electricity is easy to visualize if you think of it as the flow of water in a river. Since the flow of electrons has a specific direction in the material, and by convention, the direction opposite to that of the flow of electron is the direction of electric current. And now, what is resistance? Resistance is a measure of the opposition to current flow rather in an electric circuit. Resistance is measured in ohms, symbolized by the Greek letter omega. Ohms are named after George Simon Ohm in 1980 in 1784 to 1854, a German physicist who studied the relationship between voltage, current, and resistance. He is for formulating Ohm's law. These values are often printed on the components, nameplates, or in manuals for reference. Function of electric current. Electric current creates magnetic fields which are used in motors, generators, inductors, and transformers. In ordinary conductors, they cause Joule heating, which creates light in incandescent light bulbs. Time varying currents emit electromagnetic waves, which are used in telecommunication to broadcast information. There are two types of electric current. There is direct current and alternating current. What is direct current? Direct current is when electric current flows in any electrical circuit only in one direction, while alternating current when the magnitude as well as direction of electric current changes continuously over time but also repeats the same magnitude and direction of electric current over a fixed period of time. Function of resistance. Resistance to electricity, that is electrical resistance, is a force that counteracts the flow of current. In this way, it serves as an indicator of how difficult it is for current to flow. Resistance values are expressed also in ohms. Example of electric current. According to Ohm's law, the current is the ratio of the potential difference in the resistance. Thus, the current formula is given by I is equal to voltage over resistance. I serve as the current, V is the potential difference in volt, R is the resistance in ohm. This is an example of electric current. Example of resistance. Electrical resistance is a property of materials that allows the electric current to flow. Resistance opposes the flow of current. The unit of resistance is ohms, which is represented by the Greek uppercase letter omega. Resistors are components of electric circuits. The resistance depends on the voltage across the resistor and the current flowing through it. This is the formula of resistance. R is equal to V over I. R represents the resistance in ohms. V represents the voltage difference between the two ends of a resistor, and I represents the current flowing through a resistor or amperes. This is an example of resistance application. Electric current. Some of the common uses of electric current in everyday life as well as in scientific fields are listed as electric current is used to run many devices such as refrigerators, electric fans, and many household items. Electricity is used as electrical energy and converted into light such as electric bulbs and mechanical energy such as electric motors. Our daily life, such as public transport systems, personal computers, and water heaters, all work on electricity. And on resistance, conductor materials that offer very little resistance where electrons can move easily, examples silver, copper, gold, and aluminum. And another example of resistance is insulators. Example of it is rubber, paper, glass, wood, and plastic. Implications. Electric current through a given area of a conductor is the net charge that passes per unit of time through the conductor. To keep up a gradual current, we must have a current within which an electrical phenomenon occurs from lower to higher mechanical energy. On resistance, Ohm's law deals with the relationship between voltage and current in an ideal conductor. This relationship states that the potential difference or the voltage across an ideal conductor is proportional to the current through it. The constant of proportionality is called the resistance or the R. The relationship between current, voltage, and resistance is expressed by Ohm's law. This states that the current flowing in a circuit is directly proportional to the applied voltage and inversely proportional to the resistance of the circuit provided the temperature remains constant. Thank you for listening and may the love of God be your reward.